but I'm just going to go ahead and do my piece. So my name is Kendall. I'm the events intern for CISPA. I wanted to just really quickly say thank you all for coming. I know it's been kind of a little bit of a hassle, but we're so glad to have you guys here for this Makeup Mind Walk presentation, and we really appreciate you coming back. I just quickly wanted to introduce CISPA and the Mind Walk lecture series. So CISPA supports the 10 state parks in San Luis Obispo County in their interpretation, education, and volunteer efforts. And we are one of 89 similar cooperating organizations across the state who work in partnership with state parks. This evening, you're going to be enjoying one of our Mind Walk lectures. The Mind Walk lecture program features a variety of topics aimed at stretching the mind of the lifelong learner. And this lecture series, now as of this year, offers quarterly educational opportunities devoted to recreational, natural, and cultural history topics as they relate to the Central Coast or California in general. And this program is supported by the Thomas E. and Mary K. Ellsworth Fund. Also, I quickly wanted to do a little plug for our film night that we're hosting tomorrow. So that will be at the historic Fremont. If you guys want to come, it'll be from 5 to 8. So we're screening Out There, which is a national parks documentary. So please check out our website for more information if you're interested. Tonight, we are joined by a recently retired earth science professor, author, and educator, Bill Selby. We are so happy to have him here. He has decades of personal and professional experience with geography, atmospheric science, and natural history. He began his career in the private industry before delving into a teaching career, where he took a full-time position at Santa Monica College in 1985. He's also been a guest lecturer at UCI and UCLA, and his experiences have culminated in his most recent book called The California Sky Watcher, Understanding Weather Patterns and What Comes Next. So that is my quick little blurb. I'm going to turn it over to Bill now to tell us more about himself and get into his lecture tonight. So thank you so much for being here.
Hey, Kendall. Hello, Central Coast. Hope you're all doing all right. And finally, it's great to be with you. I've really been looking forward to this for a long time. Traveling around the state. Before we get started, I am going to fly through California with you, and we're going to visit all of the different weather patterns, hopefully, most of the different weather patterns that you might experience in different parts of California during each season. I'm going to start with summer. Before we get going there, I wanted you to see my website because I can't get this into 45 minutes or an hour. There's no way. So what we're going to do, if you could write this website down, rediscoveringthegolden.state.com. And hey, Kendall, can you see my little arrow that I'm pointing?
I sure can.
Oh, good. So it's working really well. Anyway, that's our website, and I'm going to be adding a couple of new stories to our website soon, and you'll see it goes back many years now where we've covered a lot of the great weather events and other natural history events that have occurred in California over the years, and I think a lot of you will really appreciate that. So when you say, "Hey, he's going too fast. What am I going to do here?" Well, why don't we'll figure out, get your questions ready, and we can always go back and check on the images that you wanted to spend more time on. But more importantly, you might want to go into our website, and there's a lot of more detailed information there. All right, let's roll, everybody. I wanted to start by last month, I got an opportunity to complete the UC Naturalist program. I was a contributor to the program as well. I've been doing stuff like this for over 30 years. I think Kendall told you. Well, geez, really 4 decades now. And after my career at Santa Monica College, where I taught earth science and weather and climate and a lot of those other fun classes, I decided, I want to see what this UC Naturalist program is all about. For those of you who have never heard of it, it's really cool. What we did here, we spent a week immersed in the natural history of Yosemite National Park and its surroundings. From morning until evening, every day we studied natural history, all the different aspects of natural history. And this is Greg Stott. He's the geologist up there, world famous geologist, I should say. And I'm just going to add a couple of things that we learned that were really interesting. They've put cameras up on the cliffs at Yosemite, And one of the things they notice is that when the rocks, we knew that when the rocks get hot, they expand, and when they contract, or when they get cool, they contract, right? Well, that makes sense. You get hot, you expand, you get cold, they contract. And this opens up and closes cracks in the rocks, cracks and crevices and fractures. And it turns out that that change is up to nearly a half an inch a day. So you can actually watch with these films the cracks opening and closing by up to a half an inch. And over time, of course, what that does is it weathers away the rock. It's a mechanical weathering process. And that's one of the reasons why those slabs are always falling down in Yosemite. You know, they have at least five, I believe every 5 days, they have a reported rockfall in Yosemite. And we were studying the glacial features up there. It was really fun. This is their forest, the famous forest manager up there, Garrett Dickman. And he was talking about fires. And a lot of you have been probably looking at this and studying it. But you know, we suppressed fires in California for over 100 years. That was a really bad idea. We put all the fires out that we could. And the net result is all this fuel built up in our ecosystems. And we don't know what to do with it now. We're trying to do control burning. The Native Americans knew how to do that before us, but we're trying to do that now. But there are only very specific days where you can do safe control burns during the year. And there are a lot of other reasons for that. So the problem is how do we get rid of all of this fuel that's built up over a century so that when these fires come through the forests or any place in California, they don't become these huge conflagrations. And of course, that buildup of fuel has combined. It's sort of a synergy, a negative synergy with climate change and the introduction of non-native species that act as conduits for these fires, and then our building into these natural areas. You know, we call that the wildland urban interface. And it turns out the wildland urban interface is a lot more extensive than we originally thought. And hopefully we can get to that a little bit. Anyway, that's the forest guy at Yosemite. And we met Breezy Jackson, great name, by the way. And she is the head of the Sequoia Field Station up at Yosemite. And she studies cliffs. And it turns out that cliffside environments are complete ecosystems. And we've learned a lot more about them, besides the fact that the rocks get really hot and during the day and really cold at night. And she hosted the first cliff conference. I believe it was the first one in the world up there, where all the people who know about cliffs got together from around the world and went up to the UC Reserve there. Anyway, the reason why I mentioned the UC naturalists as well is that they're coming to Cambria. In August, their program is going to be there in Cambria, their immersive program for that week. And you might check it out. It's the University of California Naturalists. And it's really fun. And, you know, you're going to learn so much in 1 week. It's just, it's like going to heaven for a week. Let me put it that way. Oh, we also learned from Ranger Ben up there. He was throwing his atlatl there, and he was showing us the dogwood. Some of you might be familiar with dogwood that grows up in the Sierra Nevada mountains. And it was blooming in April and, of course, budding that time of year. Okay. Hey, and then I ended all of this after I learned all of that. I've been doing this for years, so I had just had a whole lot of other information to add. But I was playing ranger for a weekend while I was helping the Yosemite Conservancy. And some of you might recognize this. This is the stage at the Curry Village Amphitheater. And so we had a couple of shows, one on Friday night, one Saturday night. There I am. Oh, by the way, that's not me playing the guitar. That's a lone entertainer that decided to come by and entertain the audience before I started. And we were sitting there watching Half Dome. There was a little cap cloud that formed over Half Dome there. And then I got my show started. And you're going to see some of it here. All right. So let's keep going. Oh, we even sang the Smokey the Bear song. And I wanted to mention that because this idea that Smokey the Bear always told us to put out all the fires. Well, that's true with campfires and stuff like that. But unfortunately, we got carried away with Smokey and started putting out too many of the fires. Okay, let's get started with summer in California. And we're going to start in Southern California where you have that iconic beach weather. And we're going to work our way up into Central California as well. So hang on. Oh, by the way, that's what I call the dog bone cloud formation. I caught this guy at as an artist at one of the art shows, and he's good at painting pictures of clouds. I thought that was pretty cool. Each chapter in our book, The California Skywatcher, what we do is I'll start in one section of the state. In this case, I'm starting in Southern California for the summer. And there's just too much of the state to cover in a few minutes here, but I want to focus on stable weather. So we're going to start with this beautiful weather that's so common to the Southern California coast, one of the mildest climates in the world. Oh, by the way, when you see those red sunsets up in Morro Bay and on the Central Coast or wherever they are, recognize that all of the shorter waves of visible radiation have been scattered out by that very thick atmosphere that the setting sun has to shine through. By the time it gets to your eyes, only the longer wavelengths of red, orange, and yellow are left. And that's what gives us those really red sunsets. These are crepuscular rays. For those of you who are out in nature and you know that's an optical phenomenon. If you stand in the middle of don't do this if there's traffic, of course, but if you stand in the middle of a long road in the middle of nowhere, you'll notice how it looks like the road gets narrower as it gets farther away, or train tracks too. Make sure there's no train. Anyway, of course, the train tracks on the road isn't getting narrower as you look farther away. It's an optical illusion. And these sun rays, if you want to call them that, are coming in relatively parallel fashion, but they just look closer when they're farther away. Anyway, back to our perfect weather. This is Huntington Beach, and a typical summer day on Huntington Beach. This is Paradise Cove in Malibu. Here's Malibu Surfrider Beach. And here's what it's all about, folks. We're going to spend just a few minutes. For those of you who are real weather nuts, you already know this. So just follow along with us. For those of you who haven't thought about it before, we're going to talk about the wind and air pressure real quick. And no matter where you are in the world, this works really well. So high pressure is heavy, dense air. It settles, it sinks. It's what we call stable air. And as it settles, it warms and dries. So usually when we have high pressure over us, the air is sinking and we get fair weather. Now be careful with this, because particularly along the central and north coast, when that air is sinking during the summer out of high pressure systems that dominate, it often traps a marine layer right near the surface there. That marine layer can be only a few hundred feet one day and maybe a couple thousand feet the next. The point is you can be trapped under the low clouds and the fog and not really realize that this is one of those typical summer fair weather days. It usually doesn't rain in the summer. In some summers, even in the Central Coast, you'll go from May to October without a drop of rain. And that's because the air is so stable. Now, there's another reason why the air is so stable there, and that's because of the cold water. And we'll get to that in a few minutes. Anyway, the other thing about pressure that's really important is that wind always blows from high to low pressure if you stay at the same altitude above sea level. That's really important, because whenever you've been outside and you feel the wind blowing your hair or against your clothes, what you've got is billions of air molecules trying to flow out of the high and into the low pressure. And that's what wind is. So the next time you feel the wind, remember, it's 25 billion air molecules per cubic centimeter of air are moving along, and they create there's a lot of power there. And so the wind blows from high to low pressure. Now, low pressure, of course, as you would expect, is just the opposite of high pressure. Low pressure is less dense, lighter air, and it rises. Less dense, lighter air rises, expands, and it cools, and it'll eventually cool to its dew point if the air is damp enough, if there's enough water in it. And that's where we get lots of clouds and precipitation and stormy weather. So it's pretty obvious during the summer, high pressure dominates along the California coast where we get the fair weather, even when the low clouds and fog are trapped at the surface. And then during the winter, the low pressure systems start coming in, the air starts rising, expanding, and cooling to its dew point, and we get stormy weather. So that's the basics. This is the way it looks on the average in January versus July. California is right here in both of these maps. And you can see that, for instance, in July, there's this giant high pressure system that dominates the northeastern Pacific. And that air is sinking out of that high, and it keeps our weather very stable, and it keeps the storms from moving through California. By the way, a little thermal low forms out in the desert there and sucks that sea breeze in because it gets so hot every day out in the desert. The opposite of that is pretty much what's going to occur in January, where the Aleutian low begins to dominate the North Pacific and it gets big. And so Oregon and Washington get a tremendous amount of precipitation. And occasionally our high pressure will begin to back off a bit. And these storms will come out of the North Pacific and begin to finally bring California some rain in November, December, January, February, March. You probably know that January and February are our wettest months in California. So when we get the most snow in the mountains and the most rain along the coast. And here's why. It's because our high pressure weakens. When you compare these two maps, you can really see it. And it opens the door for these winter storms to come through. I'm going to show them to you in a second. So in the big picture, there's two. This is a page out of my book, The California Skywatcher. And in the big picture, there's the center of the high during the summer. And as the air flows out of it in a high pressure system in the Northern Hemisphere, it turns in a clockwise direction. This is really important because this wind that comes from northwest to southeast down the coast, that propels what's called the California current. So that's a very cold water current. That's why if you do jump into the ocean in the middle of summer, in Morro Bay or off Big Sur or Montaña de Oro, wherever you happen to be, it's going to be really cold. You're getting a direct hit there from the California current and the upwelling from below that it also creates. So there's our cold water current. This is why we have a Mediterranean climate. Heavy, dense air during the summer, settles, stable air, hardly ever rains, and our ocean is so cold that air remains very stable over the ocean. The opposite of that would be in the southeastern United States, like even in Florida, especially. In Florida, they have tremendous numbers of thunderstorms during the summer, and that's because they got warm water all around the peninsula there. So that warm water evaporates and the very warm, moist air, which rises, that's low pressure, creating all of those thunderstorms. We don't get that. Oh, by the way, since I'm talking about that, did you know that San Francisco, Los Angeles, and San Diego, those three cities get the least number of thunderstorms per year on average of any cities in the United States? And that's how stable our air remains most of the year. Anyway, when you look down here, you can see how the high pressure puts a lid on our marine layer, regardless of where you are along the coast. For instance, in the central coast, this could be the Santa Lucia Mountains. And then on the other side would be the Central Valley. But you can see how the sea breeze gets trapped there and it can't get around the mountains and into the valley. And this is what we end up with. This is a July day. It's 57 degrees in the middle of the day as that wind whips through the Golden Gate. And the reason why it's so cold here, by the way, is that the sea breeze backs up against those coastal ranges. It can't get through, except for that one gap, and that's the Golden Gate. And the sea breeze just goes pouring through that Golden Gate. In the summer, trying to get into that hot Central Valley where the air is rising during the afternoons, and you get these really cold breezes off that cold ocean. And here we are again, 57 degrees in the middle of July here, very stable air, lots of low clouds and fog. But if you go farther inland, out into the valley, for instance, the temperatures might be over 100 degrees. You can even see the fog coming in. You all see it there on the Central Coast, and you can see it coming in over the city here. This is over San Francisco. Notice on this day, though, it comes in thick off that cold ocean. And by the time it gets a little bit farther inland, it dissipates because the air's warming up on this warm summer afternoon inland. That is very typical of what you're going to get in the Central Coast too, where Morro Bay, for instance, might be socked in with a lot of low clouds and fog because that air's come off the cold water. And then as the sea breeze comes flowing in towards San Luis Obispo and over the hills there, it heats up quite a bit. And the water, the liquid water evaporates. We call it, you've probably heard it said this way, that the fog burns off as the air warms up. And that's kind of what's happening. And one of the reasons why San Luis Obispo, farther inland, has much hotter summers, of course, than right along the coast at Morro Bay. Anyway, this fog's really important in California. Most of you know that. If you know a little bit about your plants, the plants that live right along the immediate coast really thrive in that layer of marine layer, what we call the marine layer. And when the low clouds and fog are so thick, there's actually a lot of fog drip that can occur in the forest. Up in the Northwest coast, for instance, we've measured over 10 inches of fog drip that falls during the summer. This is fog that's flowing over and through the forest, and it's caught by the forest and it drips down to the forest floor. And so that keeps these tallest trees in the world from drying out during that summer drought. And it is a little bit shorter summer drought up in Northern California, of course. But here's a place that gets almost 100 inches of rain a year, but that's in the winter. During the summer, it's quite dry, except for that fog that's drifting in and is caught by these trees and then drips down to the forest floor. And for those of you who know Northern or Central California pretty well, you're used to this look, that fog coming off the cold water. This is up at Big Sur, typical marine layer sunset. And what's really interesting, I think to me, and I hope to you too, because you see, I don't like this stuff, right? I'm not having as much fun as you think. Seriously, the direction of the wind during a particular day will determine whether it's sunny in this little cove or overcast and foggy. For instance, if there's a little bit of a breeze from the northwest, it'll protect a cove that's facing southwest, and you'll get some sun that summer day. But if there's a breeze coming from the southwest and you're facing the southwest, you'll probably be fogged in all day. And so as you go drive through the Big Sur coast, you get to go in and out of these sunny and foggy coves, depending on which way they're facing, toward the wind or away from the wind. And this is one of my favorites from Morro Bay. I was up on Black Hill when I took this picture. Sunset in Morro Bay, we have a strong high pressure system over us. The air is sinking down and it's trapped a very shallow layer of fog and low clouds right near the surface of that cold ocean. So, of course, the air down there near the ocean has chilled to its dew point. But the inversion, above the inversion, I should say, it's warm and dry and sinking air. And on that particular day, Morro Rock stuck up from the fog. On so many other days, you might see the fog skimming over the top of Morro Rock. And that would be an indication that the marine layer is a little bit thicker, of course. And you can even see the bottom of the low clouds on those days, but not on this day. I love this because if you're standing there next to Morro Rock, you'd be under the fog. You wouldn't be able to see very far. And so if you're looking at the sea otter swimming around and so on, it's probably not the best day to do that. It could be like 57 degrees down in there in the fog, and up on Black Hill there, just above Morro Bay, it could be 80 degrees. And so you see the low clouds and fog coming in San Diego, that's La Jolla. They don't get quite as much as you all do up there because their water's a little bit warmer. This is from the Santa Monica Mountains. And by the way, this is, if you look into the foreground here, this area is the whole area that burned in the Palisades fire. But I took this obviously long before the fire. But again, you can see how the marine layer is clamped down near the surface of the ocean there. The Palos Verdes Peninsula sticks up in the background. And this is what it looks like in a satellite image. This is our marine layer on steroids, I guess you could say, from the Oregon border all the way down to northern Baja. And you can blame that cold California current. When the summer air comes up against that current, it chills to its dew point. The fog and low clouds form, and they try to move inland, but they back up against all of these mountains. Occasionally, they creep into the valleys, like the Salinas Valley here. Occasionally, they creep into the Bay Area, all the way in toward Livermore and over the Oakland Hills. And here you can see them all the way into the valleys of Northern California, but it's not getting into the Central Valley. And on this particular day, by the way, that was back in June of 2021, they were experiencing record high temperatures in the deserts. So we got two very different, radically different climates. The folks on Morro Bay and the Central Coast and Big Sur were fogged in, and it was probably around 58 degrees, 60 degrees. Out here, it's like 110 degrees out in that desert. And all of that is because of these mountains that block that sea breeze from getting into the deserts. So again, still dealing with summer here. When the marine layer gets thick, it looks like this. This is off of San Diego. And this is just in Southern California, but it's true with the Santa Lucia Mountains too. When the summertime high pressure is very weak, it allows the marine layer to thicken up quite a bit. And the low clouds can move all the way in against the mountains. If you live along the coast, you might have a cloudy day during that entire summer day. It might go on for a couple of days when these low clouds back up against those mountains. So that's the case anywhere in California. The opposite of that is what we were looking at before. When the marine layer is very shallow, it doesn't get in as far, and you end up with very hot inland valleys that don't get the sea breeze. Also, in places like Southern California, the marine layer is trapped up against the mountains. So the sea breeze blows the smog from the cities into the inland valleys, and then the mountains trap it from there. And that's pretty typical. That's why the inland valleys of Southern California, and by the way, the San Joaquin Valley, are still the smoggiest places in the United States. Part of that is just because our inversion layers, especially during summer, they trap that smog layer, and then the smog can't get out in the desert because the mountains are blocking it. Okay, let's race into the hot Sacramento Valley during the summer, where temperatures can get well over 100 degrees. In fact, in Redding, which is the northern end of the valley, most of you know, a typical 100-degree day is fairly average here. I think the average high in July is 98. So why? They're so far from that delta breeze, and the sea breeze can't get over the mountains and into Redding. Let's zoom up toward up the slopes of the Sierra Nevada to the largest in volume trees in the world, and those are our big sequoias, and they are being nurtured by snow melt that soaks the soils, and hopefully those soils don't dry out too much during the summer so that these trees can thrive. Occasionally you'll get a summer thunderstorm up there that'll help out a little bit during that dry season. But, the dry season, of course, typical of Mediterranean climates, is that time of year when all of the plants are going to be under stress. We get up into the high country. This is above the tree line. And think of trying to be a plant living right about there. So throughout most of the year, you're covered with ice and snow, and the winds are blowing like 50 miles an hour, and temperatures are below zero. And then finally, when all that snow melts in June and July, all the water flows downhill and ends up here. So you're stuck in a very dry environment in late summer, and then you get covered with snow throughout most of the winter. And, there aren't many species of plants and animals that can live in environments like that. But I talk about them in my book, and you'll learn about them on our webpage. This is also above the tree line, up over 11,000 feet. Oh, I wanted to share with you very quickly what we call these vegetation zones in California, particularly with the taller mountains like the Sierra Nevada. And I've got this in the book too, but I think most of you know that when you travel from the lower to the higher elevations in our major mountain ranges, you're going to go through these different plant zones as it gets cooler and wetter. It's almost like you're traveling from Mexico to Canada in many ways. And so that's pretty interesting. This is the high country in the Trinity Wilderness, which some of you might be familiar with. It's as you get up toward the Oregon border there. And of course, this is the other side of the mountains. We call it the rain shadow. The storms don't get out here. In fact, so far this year, um, let's see, this season it is. So far this rainy season, Death Valley has received 0.36 inches of rain, about a third of an inch of rain. And of course, that's why it's so dry. There's an alluvial fan. I have a discussion of that on our web, several discussions on our webpage in the book as well. When you go to the high desert, it gets a little bit damper. There's a little bit more water up there, and they even get snow in the winter, occasional snowfalls that might stick for a day or two. Up in the Joshua Tree woodlands are examples of that high desert. There's lots of animals that have adapted to those very dry rain shadow climates. And if I told you you were on the Oregon border here, would you believe me? The Oregon border is right behind me when I took this picture. It's true. You have the Warner Mountains out here, and beyond them is another mountain range, the Cascades, and then beyond them is the Klamath. And all of those mountain ranges have blocked moist breezes from getting from the Pacific into these inland areas. And you end up with this amazing rain shadow up near the Oregon border. And by the way, this place gets about just a little bit less rain per year, a little bit less precipitation because some of it falls as snow, a little bit less precipitation than Los Angeles. And here we are on the Oregon border. It shows you the power of the rain shadow being on the opposite sides of the mountains. I'm not going to spend much time with this. If you're interested in summer thunderstorms and that monsoon moisture that we get during the summer, it forms when there's a high pressure system, usually somewhere around the four corners, and the wind that blows around that high, it scoops up a little moisture out of Mexico and brings that monsoon across the desert Southwest and into California. Here's another typical, hey, are y'all there still? I figured I'd stop and ask. Here's another typical satellite image for summertime. We have our typical marine layer here. It looks like Morro Bay is pretty much socked in the entire central coast. There's Monterey Bay. There's the fog trying to get through the Golden Gate. And Southern California is pretty clear here. But man, that's cold water. Over on the other side of the mountains, though, here's that monsoon moisture creeping up and flowing from southeast to northwest. And I'll just follow it. Here we are at Joshua Tree, where we had a little bit of moisture sneak up on that summer afternoon. And in late afternoon, the cumulus clouds started to form, and they look like this. By mid-afternoon, we had these big thunderstorms forming over the desert. So this is our monsoon. I got lots of stories about monsoon moisture and these beautiful thunderstorms, summer thunderstorms that you're just not usually going to get on the Central Coast. The water's too cold. Once these storms get over to the other side of the mountains, they're pretty much dissipated if they ever make it that far. Now, we don't get hurricanes in California because of the cold water, and they do get hurricanes out here in the Gulf and, of course, off the southeast coast of the United States because the water gets very warm there. Water temperatures get way up over 80 degrees off in the Gulf of Mexico and off of Florida, but not here. We have to go all the way down south of Cabo to get the really warm water. And that's where the hurricanes and tropical storms form during late summer, usually. This was a particularly weird storm because it was big. First of all, Hurricane Hillary back over a year ago now. And it was only 2 days away from Southern California on this satellite image. It was one of those very few in history hurricanes or tropical storms that was able to make it into California before it completely dissipated. And it created a lot of really interesting weather, including like 5 inches of rain on the mountain slopes. And then a whole bunch of problems with flash flooding out in the deserts, including Death Valley, that had its wettest single day in history uh, as that dissipated storm moved up through uh, the deserts there. And then we have these high pressure systems that form over California during the summer. You notice I'm focusing on summer because we're getting there. And these create our big, bad heat waves. When the air is really sinking, it drives the sea breeze and that marine layer way out to sea, and the air just gets hotter and hotter over time. During the end of our mega drought, which started at the beginning of this century and went on for more than 20 years, we had some of the worst fires we've ever had in California by far. This was one of them. It was the Creek Fire, and it's supposedly was the largest or tallest pyrocumulonimbus cloud. That's just a cumulonimbus cloud or a thunderhead that's created by a fire. And you can even see how the wind is pushing the top of that giant smoke cloud from southeast to northwest. Here's what it looked like from the side. And this was sort of the end of that mega drought, near the end of the mega drought when the forests had all dried up and we had terrible problems with our fires. You had them in the Santa Lucia Mountains as well. Um, and some of them were lightning caused. And here's some of those fires in Northern California in 2021. You can see the smoke turning around the high and headed out toward the East Coast on that one. And this is what we ended up with. Okay, this is up at Mount Lassen. We're in the northeastern part of the state, and it's time to go to fall. Okay, during autumn, things change. Of course, one of the first changes that we can look forward to is that the land begins to cool off very quickly. And so a giant high pressure system called the Great Basin High will often form here. Notice how during the fall, during the autumn season, the pressure patterns reverse. So all summer long, we had a sea breeze trying to get out to the deserts. Now we're going to have land breezes during the fall, and this changes everything in California. First of all, we get those beautiful colors, mostly up in the east of the Sierra Nevada mountains. This is north of Bishop. By the way, steam fog is kind of interesting. This is at 10,000 feet. Tioga Lake was warmed during the summer. It's now toward the end of summer and beginning of fall, and the air is cooling off. So the water evaporates into cold air that can't hold its water vapor, or it has a lower capacity to do so. And you end up with steam fog. It's very similar to when you go out on a cool, moist night and you blow out and you see the steam fog coming out of your mouth. There's lenticular clouds, and I got stories about them. And this is the way our fire season looks in the western Sierra Nevada mountains. You can see how dry everything is. And by the way, you have these problems along the coast too, and up in the coastal mountains of Central California, where non-native, aggressive non-native species of plants, especially grasses, have invaded, and they act as conduits for fires now. It's a real problem throughout the state of California. Once we end up in July, August, September, and into October, assuming that it doesn't rain. It's a whole story about bears and how they got to fatten up on acorns, which happen to be ripe during the fall season. We were in a field trip here. I was with my students, and this bear climbed right out over the road. She was swatting acorns on an oak tree that hung over the road, and then she came down to eat them. A whole There's just too much to talk about when it comes to fires lately. But we have mapped out this threat throughout California. And for those folks along the Central Coast, you can see that the Santa Lucia Mountains and also the mountains here above Santa Cruz, the Santa Cruz Mountains, are all fire prone. By the way, I do have a website story about this, about Big Basin State Park. And I went up there last summer to see how it was recovering from the terrible fire that just burned everything to the ground up there in that redwood forest. And you probably already know that the good news is that the coast redwood trees recover. And they actually, I think it was 97% of all coast redwood trees that were burnt, completely burnt, were actually still alive, and they've sprouted ever since. They started looking like big bottle brush trees. So we'll see how that goes. Anyway, you can see where the fire threat is. It follows our mountain ranges all throughout California there. And tree mortality, I have a whole section on that. And here's the way the satellite image looks. Look how different this is now. During the fall, we get these offshore winds where the high pressure now, the higher pressure is launched farther over the land. And this creates these offshore winds that push the sea breeze out. You can have a day here along the central coast, right at the base of the Santa Lucias. You can have a day where the temperatures get over 100 degrees in September and October. And sometimes these are our hottest times of year, all the way from Northern California down to the Southern California coast because of those offshore winds. Here's the way it looks when we get the offshore winds flowing from the inland areas into the coast. You know, they're not hot when they get here and dry because they came from the desert necessarily. They're hot and dry because they get heated by compression. So sometimes these winds, these offshore winds, will skim right over the Central Valley, up over the coastal ranges, and right down to the Central Coast, right here, where they get heated by compression. And if we haven't had a rain yet, this is going to be a problem. So it's always a race every year. When we get to autumn, is the first rainstorm going to come, or is the first offshore wind going to be here first? If the first offshore wind comes and beats the rainstorm, we'll probably have a terrible fire season. If the rains come before the offshore winds, we might not have much of a fire season. And even the Bay Area clears out during these periods. This is from the Oakland Hills to San Francisco. And the dinosaurs don't like Santa Ana winds in Southern California either. I hope you're laughing because that's not a real dinosaur. If there are any young folks out there watching, this is in San Gorgonio Pass or Batting Pass during a Santa Ana wind. Up in the Bay Area, they call them Diablo winds. Down in Southern California, they're called Santa Anas, and that's what they look like. And this is what they often produce if those first winter rains don't come first. 2018, that fire burned all the way down to Malibu, and it stopped only when it got to the ocean. It was quite a disaster. And when we have these offshore winds, this is what it looks like on a satellite image. You can see the smoke pushed hundreds of miles out to sea. By the way, these are just cirrus clouds here. And then we already saw this, so I have to keep going. Now, we're transitioning toward winter. And look at how the map starts to change. This is an upper level map that shows a deep low pressure trough over California. And this is probably not going to happen during the summer. So when we get that transition from summer to winter, that high pressure system will start to back off and weaken. And then these low pressure systems and these troughs will start to swing into California. And that's what's going to give us cyclonic flow. The wind blows counterclockwise and storminess. And a lot of that moisture is pushed up into the mountains. We get the different types of clouds, altocumulus above, stratocumulus below. This is what this is what the weather map might look on a winter day, or late fall for that matter. And so we've got LA right here. There's the Monterey Bay. There's the Bay Area. If you look very, very closely, you can see the Morro Rock. You see it right there? Okay, that was a joke. I was just trying to make sure you're paying attention. This is the entire Pacific Ocean, pretty much. There's Alaska up here. So the series of these storms, they're low pressure systems that turn counterclockwise, begin to fling into California. And that brings our rain and snow season. Of course, that's pretty typical of a Mediterranean climate. Here's a bomb cyclone up along the Northern California coast, or Oregon coast, and the Northern California coast is getting the cold front. Now, the question is, how far south will this cold front get as this storm circulates up here? Doesn't look like it's going to make it to Southern California, but maybe to Central California if we're lucky. There's a big old cumulus cloud with a ton of water. Here's a thunderstorm I caught over the mountains, and I was real happy about that because we just don't have many of these along the California coast for reasons that I mentioned before, and even caught a lightning strike there, which is pretty cool. Um, this is pretty typical of a stable day as we get toward late fall and into the winter in California. And you'll notice the valley fog. This is a completely different kind of fog than what we get along the coast in the summer. This is a wintertime event. And what happens is the cold, dense, heavy air settles in these inland valleys and it eventually reaches its dew point. The sun's very low in the sky in the day, and the nights are very long. So those temperatures keep going down until the air reaches its dew point and the tule fog or the valley fog forms. You can see it in the Central Valley here, in the inland valleys of Southern California, all the way up to Salinas Valley. You can even see it up here along the Eel and Klamath rivers in those valleys. And then it kind of merges with a marine layer here. So this is a pretty foggy day in much of California. Not in the mountains. The mountains stick up above all of that fog. And this is one of our typical late fall and into winter storms. I just wanted to show this to show you how this counterclockwise circulation will bring warm, moist air in ahead of the storm and very cold air behind it. So as these storms approach, when you're along the central coast, you'll get a southerly wind, sometimes southeasterly, southwesterly. And as they approach, you're going to get a lot of heavy rain. And then as the cold front finally moves through, the temperatures will drop. The tops of the San Lucia Mountains will start to get quite a bit of snowfall, hopefully. And then things will clear out in that colder air behind the storm. And I have a whole section about watching the clouds at night. And now we're into winter. Just one thing about winter that you all know already, I think. The jet stream up here will begin to dip south in the winter. And occasionally a trough of low pressure will send it down over California. But Northern California is much closer to the average path of the jet stream than Southern California. You folks on the Central Coast are right in between. So while they're getting all of this heavy rain, you might get an occasional front that goes through, right? And maybe Southern California will get nothing. That's exactly what happened this year. It started in October and November and December, and it rained up in Northern California. They got some atmospheric rivers through there, and nothing got down to Southern California. In fact, there was kind of a bipolar effect there. There was a wet Northern California, super wet, and an extremely dry, the driest period from spring to through into January that the Southern California coast had ever had. That meant, what does that mean? Well, a tenth of an inch of rain fell from spring to mid-January here in Santa Monica, as an example, which is one of the reasons why we had those terrible fires. Anyway, back to winter. That's when we get to see some rainbows, perhaps. Note that, again, this is when the low pressure has dropped south and some of these storms come in. One of the very important, well, it's one of the most important events that happens in California in the winter is what we used to call them the Pineapple Express, where air that's spinning around this deep low pressure system up here. The winds are brought across and from near Hawaii, across the Pacific, and right up into California. And this moist air hits our mountain ranges and dumps tremendous amounts of precipitation on California because our mountain ranges run nearly perpendicular to these shots of very moist air that are moving in ahead of these storms. Anyway, we call them atmospheric rivers now. When troughs of low pressure systems or troughs of low pressure form like this, they drive these atmospheric rivers from across the Pacific into the state. And it turns out that atmospheric rivers deliver something like half or more of all of the water that falls on California every year. And that means it falls within a period of just a few days. Most of the water that we get falls within just a few days or a couple of weeks. I don't have time to talk about El Nino and La Nina. But since I'm talking about El Ninos, or I'm talking about atmospheric rivers, moving along here, this is just one year. 2017, we had flooding in Northern California. Each one of these arrows is an atmospheric river that hit the West Coast. And I have whole discussions about these storms as they approach the coast. Here it comes up to the central coast. The storms are turning up here, the big low pressure system counterclockwise. And here's that atmospheric river driving right into California, delivering a tremendous amount of precipitation. On this map, it's a big one again. There's the Pacific Ocean. Here's California. There's Point Conception and the Bay Area. You can see this low pressure trough is right off the coast. So we'll be getting the heaviest rain right now. And if these patterns of troughs and ridges are flowing across the Pacific, as they are on this day, we'll get a period of storminess, and you'll get some heavy rain on the central coast from this. Then a ridge of high pressure will move in, and we'll get a nice day or two. And then right behind it, another trough and heavy rain with that. On the surface weather maps, we don't have time to talk about the warm fronts and the cold fronts that form with these what are called middle latitude wave cyclones. But these are the storms that bring us rain and snow in California. Thank goodness, right? And you can go to the National Weather Service site or to my website, and we've got this nice diagram which shows how atmospheric rivers drive all this water up. And as the air hits the Santa Lucia Mountains, for instance, it's forced to rise even faster. That creates tremendous instability and a tremendous amount of rainfall. By the way, I've seen many winter storms where, say, Morro Bay will get an inch of rain, and the slopes of the Santa Lucia Mountains will get 4 or 5 inches of rain. This is not unusual, where you can get 2 or 3 or 4 times more rain up on the mountaintops of those mountains than right down near the beach before the air gets that boost to go uphill. On the side view, this is the way it looks. So if you say the Santa Lucia Mountains are here and Big Sur and Morro Bay and Montaña de Oro are down here, notice how the air just starts to rise over those coastal slopes, and then heavy rain falls on the slopes facing the ocean. Then it dries out a bit in the Central Valley where they don't get as much rain. And then again, heavy rain and snow on the western slopes of the Sierra Nevada. Finally, when we go to the opposite sides of the biggest mountains, we're in the rain shadow. And so, of course, this is our high and low desert areas where they just don't get the rain that you would expect on the Central Coast. How big are these storms? Here's one that brought over 100 inches of snow in 4 days to Northern California. Here's what Mammoth looked like in 2024, in the spring of 2024. Here's what your coast looks like. I think I took that north of Jenner, so it's a little bit farther north, way up above the Bay Area there during one of those winter storms. You've seen this before, though. It churns up the water, and this organic material forms foam. This is not pollution, by the way. Here's one of those storms sweeping in again, counterclockwise flow, driving that warm, moist air ahead of it and creating all this precipitation over California. That's a cumulonimbus cloud behind a winter storm. Here's some cumulus clouds. Another thunderstorm forming out in the ocean. These are called mammatus clouds. They often form near thunderstorms, or at least where the upper air is very turbulent. You have strong up and down drafts. Here's another atmospheric river. This one is bent over a little bit. You can see there's a counterclockwise movement of air, and here it's driving very warm, moist air right up into central and southern California, right over Point Conception in this case, and into the Sierra Nevada mountains. There it is passing by California. You might know the story of the Oroville Reservoir and its spillways in 2017. Came within about an hour or two of failing. That's a great story. I got it in my book. It would have been the greatest natural disaster in the history of California, and we missed it by an hour or two, thank goodness. All the different kind of cloud formations. There's Mammoth again. This is just in 2023. This is the atmospheric river that buried Yosemite just 2 years ago. That's Curry Village. Those are the tent cabins. That's all that's sticking up from the snow depth there. There's a sign at Yosemite Falls. Once we get on the backside of the Sierra again in the winter, we're in the rain shadow. This is at Alabama Hills. Again, the air has to sink to get into the backside of the Sierra Nevada mountains, and that's why the desert is out there. Down here in Southern California, San Jacinto Peaks blocks these storms as well. Got a couple pictures of mammoth during the drought. Remember that mega drought ran on and off from about 2000 for a little over 20 years. This was around 2011 at the top of Mammoth Mountain in late December, and there's no snow. Look over the minarets. It's just pathetic. A lot of stories about Bodie. If you've been up there, that's a cool place to study weather.
I just
Uh,
wanted to interject super quick. We have about 5 minutes till 7,
Good,
just so you
good.
know.
Okay, I'm on it.
Um,
I'm on it. So we'll
okay.
wrap it up here in a couple of minutes.
And also just for
Currently,
the audience, if you want to start thinking of some questions, we're gonna have a Q&A at the end. So,
we want to get the questions in.
yep.
So a lot of people don't know that the Bigfoot legend started in northwestern California. And so finally we get to spring, and Kendall, this is the end. I'll run through these real quickly because we've gone through the most important weather patterns, I think. We can't do them all. Carrizo Plain, as most of you must know, is one of the best places to see the super blooms in California, and one of the last places where you can see what the California prairies once looked like before we dug them all up. And so that's what spring in the desert looks like. This is down at Bregel Springs. This is our poppy fields in spring. Got a whole story about the wind coming through the canyons there and Ventifax. And there we are again in the rain shadow. And oh, one other thing. Did you know that tornado frequency in California, there's more tornadoes in California than any other place west of the Continental Divide. The Los Angeles Basin and the San Joaquin Valley have more frequent tornadoes than any place west of the Continental Divide. Now, they're not as big as the Midwestern tornadoes, but there's a lot of reasons for this. And we go over this in the book and on our website. Here we are in the Owens Valley. The wind, spring is often a time of wind and various swirls of air that we call eddies that force that cold fog and low clouds up against the mountains. Here's a big Catalina eddy in Southern California where we get thick low clouds and fog that boil over the mountains, back up against the mountains here. There's our high pressure. It's reasserted itself. Summer's here, everybody. Got a whole section on how birds fly and how the plants respond to fire. This is just 16 months after that Zuma Canyon fire I showed you. Oh, can I? You know what? I'm going to end with this, if it's okay with you, Kendall, so we can get to some of our questions. Throughout California, this pattern repeats itself. North-facing slopes facing away from the vertical rays of sun stay cooler and damper. The soil doesn't dry out as fast. And so look how green this is. South-facing slopes facing into the direct rays of sun, those soils, they dry out much faster and they tend to be more xeric. You can see this all across California landscapes, north versus south-facing slopes, wet versus drier slopes. Here's upslope fog at El Capitan and Yosemite Falls. Here's the runoff during an atmospheric river. The water got up to this level in Yosemite Valley in 1997 when there was a tremendous atmospheric river that came through here and it melted all the snow at once. Anyway, Yosemite Falls is in the background, Mirror Lake there. We could talk about our water supply. We don't have time for that. But we will end with Mount Shasta, I think. Oh, yeah. And the sacred rain arrow. By the way, this wasn't a California native sculpture. This came from the middle part of our country. But I thought I'd do my rain dance for you here because we need it down here in Southern California. I know up in Northern California, they got about a decent amount of rain for the season. And you folks right there in the Central Coast are right in the middle. You're that dividing line between what was a average year toward the north and a very below average year in rainfall to the south. we're stuck with what we got now. The drought season is starting, and there's nothing we can do about that. So let's see what happens in the next several months. All right. I'm going to move ahead here while we're looking for questions, aren't we?
Yeah, we have one question. If you want to answer that now, or if you have any closing statements.
Well, I was just going to say it would be fun to come back and talk about climate change because I knew we couldn't have time for it today, but I have a whole, it could take another hour where we talk about the different climates of California, why we have one place up here near the Oregon border that gets 100 inches of rain a year, and another one down here and here that gets around 2 inches of rain a year, and what a what our climographs look like. And this is typical Mediterranean climate there, San Diego versus Eureka. You folks in the Central Coast, you're right in between, where it's really wet and cool year round in Eureka, and it's warmer and much drier in San Diego. Your total precipitation and average temperatures fall somewhere in between these two. All right. And there's a whole section on the Palisades fire. I've got that on my website. You can check it out. And I wanted to show you, and we don't have time for this, some pictures of native vegetation right here in my own neighborhood. So this is what I've been doing to answer your question, Kendall. This is what I've been doing since I retired. Some of the things, besides writing the book, the California Skywatcher book, my latest, you can see the list up here. My latest endeavor is pickleball, which is pretty fun. And these are all classes I've taken since retiring. So I've had fun with that. Don't forget our website. It's right here, everybody. Rediscovering the Golden State. And I'm ready for questions if you are.
Okay, awesome. Thank you so much. We have a question from Claudia. Hi, Claudia. She asks, how will offshore wind affect weather patterns and fog on the Central Coast? The Central Coast fog keeps our native pines alive in the summer.
Okay, so if you could speak a little bit more clearly, because your voice in my computer for some reason, because we know we have a ghost, Kendall, you and me. There is a ghost somewhere between you and me. It's a little bit muffled, so I only hear
Okay,
like
let me
half
try
of
one more time.
it. Yeah.
How will offshore wind affect weather patterns and fog on the Central Coast? Claudia says the Central Coast fog keeps our native pines alive in the summer.
Yeah, so this is really important. Great question, by the way. This is why the coastal areas of California, by the way, are not deserts. I often had to get this across to the people I talk to out there and also my students when I was teaching these classes, because people say, well, Southern California was a desert. It wasn't, nor was the Central Coast a desert. These are Mediterranean climates. And one of the reasons why they're Mediterranean climates is we got that late night and early morning low clouds and fog, otherwise mostly sunny during the afternoons weather forecast that repeats itself over and over and over again almost all summer long. And so that sea breeze and that fog and those low clouds cut down on evapotranspiration rates along our immediate coast. And that's not happening in the inland valleys where they're drying out really fast during the summer. And this has produced or helped to produce what we call a coastal sage scrub plant community. Now, when you make your way away from the coast, we call it soft chaparral, by the way. You see, they don't get as much rain right along the immediate coast during the winter, but the relative humidities stay much higher during the summer along the immediate coast. The fog and low clouds and that high relative humidity cuts down in evapotranspiration rates. And that is really important for those plants to survive throughout that long drought period. And you'll notice that they have softer leaves. Now, as you move inland, you'll notice that you go into the chaparral and oak woodlands and so on, and those plants are much more adapted to drought and hotter summers. and they'll have hotter leaves. They have hotter summers, so they have harder leaves. We call them sclerophyll leaves, the hard waxy coatings on the leaves. They cut down on evapotranspiration rates from each of those plants, and they save them from dying during that summer drought. Now, I think the question was, how do these wind patterns determine where the fog might be? And that kind of gets back to a point I was making earlier when we were talking about summer. You'll notice if you're traveling along the central coast or the north coast and even the southern coast, that the exact direction of the wind will determine whether that cove or that point that's sticking out is foggy or clear. And again, for those landscapes that are facing towards the southwest, if you have a northwest breeze on that afternoon and your landscape or cove faces toward the southwest, you might be clear that day because you're blocked from that direct hit of the sea breeze. On the other hand, if you're facing the southwest and the southwest breeze comes off of the ocean, that's going to push the fog and low clouds up into your particular locale. So, we have a very jagged coastline. In some places, it faces the southwest, and in other places, the northwest. And sometimes that fog will come barreling down from the northwest with the northwest wind, and all those places facing it will get the fog. Other times, we'll get a surge of fog from the south, and it'll push the fog up against those slopes that are facing southwest. So it just depends on your particular slope aspect, and it really makes a big difference. It can determine whether you're going to have a sunny day along the coast or a cool, foggy, misty day. Did I answer that question? I hope. If not, keep it up.
Yeah, I also just want to tell folks that there's a Q&A feature at the bottom of your Zoom screen that you can type questions in if you're missing that. But in the meantime, I actually have a question.
Mm.
Um, you talked about Hurricane Hillary, and I was wondering if we could expect to see more hurricanes and hurricane remnants in California as the climate continues to change. I know you didn't really get to get into climate change, but is that something that might happen?
Oh, oh my goodness. And this is why we need to do a session on climate change. The answer is nobody knows. Okay. And the reason is we've never run this experiment before. So there's a couple of things happening. And in a way, you did ask two questions there, but you don't know it. But we know that hurricanes require and tropical storms require water temperatures of at least 80 degrees. So you're not going to see any hurricanes or tropical storms forming off the coast of California, even with climate change. Okay. Um, but what is happening is as the temperatures of the oceans increase, and they are, and by the way, our water temperatures globally are not only increasing, but that's causing an expansion of the water, which is the main reason for our sea level rise, which is 7 to 8 inches since the Industrial Revolution. So as the ocean gets warmer, it expands. Anyway, getting back to the point, you nailed it on that, Kendall, because what's happening with warm water is more warm water is likely to evaporate. Well, obviously, when you get warm, it evaporates faster. That means that the air above that warm water will be warmer. It can hold more water vapor. It has a higher capacity to hold water vapor. That means there's a lot more water and energy in the atmosphere. And that's why tropical storms and hurricanes form over warm water and not over California water. Now, your question is like this. If our water temperature is increasing, could that mean that something like Hillary could happen again? And I'm going to start by saying maybe. And the reason for that is that if those storms are getting more powerful off the coast of Mexico, which we would expect them to do, they're still going to have to go up over cold water to get to us. But if they start out stronger, they're more likely to hold together a little bit better before they get here. And that's what Hillary did, right? And it helped to have her moving really fast. Hillary went from off the southern coast of Baja to San Diego in 2 days. And that's about as fast as one of those storms can move. Okay. So that's number one. Yes, it's possible that the frequency of tropical storms and hurricanes that are dying over California once they get here, it could increase that frequency. Uh, but we're talking about that's pretty rare as we go now. Now, there's another thing you reminded me of. What if people ask, is the fog going to be more consistent or less consistent as the temperatures warm up? Because, California is a couple of degrees warmer now than it was 100 years ago on average. That depends on where you live. And that is a big mystery. And here's why. If the waters are warmer, that would mean that the air above that water is warmer and fog would be less likely to form. But the problem with that is if more warm water is evaporating faster into warm air, that will put more water into the air. So not only is the air going to be warmer, and it already is on the average, but there'll be more moisture in the air. And we already have that. We're already measuring that on the average. And when you combine those two, it's possible that we'll have just as much fog in 50 years as we have now. Nobody knows for sure. One of the things that could happen, which this is really interesting, we already see that the inland locations are getting much hotter faster than the coastal locations. This temperature variation, this temperature gradient, is creating a much stronger summer afternoon pressure gradient, which could, it's reasonable to assume, cause the sea breeze to be stronger, and the fog might even get more persistent during the summer afternoons. So again, an experiment we've never run before. From a scientific perspective, it's really exciting and all of that. From a humanitarian perspective, it's tragic. And if you want to see the tragedy, you just turn on the news every night. You can see it happening every day now.
Thank you. I think we have one more question from Catherine. Hi, Catherine. Catherine says, in the Atlantic, there is concern that ocean currents may collapse and reverse. Is there any concern of that happening in the Pacific with the coastal current that brings cold water south?
Yeah. Let me see if I can get a good ocean current here. Just take a second for me to back up enough. I hum while I'm going through these. I hope that's not wasting all of your time. These are slides I could have shown if we did. Let's just stop it right there. Okay, so what we've got is we've got the Pacific Gyre. If you look carefully here, this is the West Coast. This is the North American continent. And this is all the Pacific Ocean. There's a storm brewing out there, folks, right there. You can see it. Anyway, so what we have is an ocean current that flows clockwise in the North Pacific. By the way, this is true with every major ocean and up against each continent on the Northern Hemisphere. There's a clockwise gyre of ocean currents. We call it the California current here. It flows down near the equator. It flows out toward Asia. And by the time it gets there, it's warm. So they have a warm water current here. So it turns cold as it's moving up here, and then it's cold when it comes down California. So the problem that we have in the Atlantic is much more easy to understand, I think, because right to the north of the Atlantic Ocean is Greenland. And Greenland is melting, the ice sheets are melting. And as that clear water melts, it's lighter or less dense than salt water because it doesn't have salt in it. And so as it melts, the water from the glaciers flows over the ocean, and it could theoretically block what's called on the east coast of the United States. This is the east of Asia again, but on the east coast of the United States, it could block that Gulf Stream that comes up the east coast. And that would be really bad news because that Gulf Stream keeps the northern Atlantic warmer, and it also keeps Europe warmer because it eventually gets to Europe. So yes, that's what Cynthia, was it? What was her name?
Catherine.
What? What's that?
Catherine.
Catherine. Yeah, Catherine. So, Catherine, that I think you were referring to the possibility that the Gulf Stream could be blocked. There's already indications that that's starting to happen. And then, if that warm water isn't pumped up to the North Pacific and toward Europe, that while the rest of the world is warming up a few degrees, that northwestern Europe could freeze over, and that's possible. Now, the question is, can that happen in the Pacific? I don't know. All right. I haven't seen much research on that yet, but we don't have a big Greenland sitting up here ready to melt with fresh water flowing down to block this warm water coming up here. So I am going to start out by not knowing what I'm talking about, saying, I don't think this is going to be an issue for the Pacific. Now, can ocean currents change for other reasons? Absolutely. And in fact, it could be possible that when the Atlantic Ocean currents are interfered with, it's going to change the ocean currents across the entire world, at least indirectly. That's possible. But I don't see that we have that same exact geography that would block a warm current from coming up the east coast of Asia, such as they do there on the east coast of the United States. I hope that wasn't a too confounded answer. But again, it goes back to what we don't know is far more important than what we do know now. And it's just an experiment we never run before. And we're really playing with literally, we're playing with fire here, folks. And as the temperatures go up globally, there's more energy being trapped, long wave energy is being trapped in our atmosphere by these greenhouse gases. And as global temperatures on the average rise, nature's going to distribute that extra energy somehow. And she's doing it right now. You can see it everywhere, where convection currents are moving faster, low pressure systems are getting more powerful, droughts and high pressure systems are more pronounced. And so, I mean, my summary of that would be put on your seatbelts. You're in for quite a ride. And if you're expecting things to calm down, you're going in the wrong direction with that. Nobody who's doing research right now in the scientific community is looking forward to a calming of these systems. More energy means more change, and that's what we're going to have to look forward to. So let's all kind of get ready for that change, but at the same time, figure out ways that we can make positive change ourselves.
Well, I think we're going to wrap up here unless anyone else has another question that they want to type really quick. But Bill, thank you so much for doing this presentation for us. It was super informative. I know you couldn't get through everything you wanted to get through. It's just so much information, but we really appreciate what you could get through. And thank you all in the audience for coming. I know it was kind of a bumpy ride here, but thank you for coming to this make up mind walk, quote unquote. So we really appreciate you guys, and Bill, we really appreciate you. So if you have any closing statements, I'm going to turn it over to you one more time.
Hey, Kendall, can I add something?
Yes,
It'll just be another half hour. No, I'm just kidding.
maybe a little shorter.
If anyone has any other questions, Kendall, feel free to give them my email. You've got it, and I'll be able to answer those. I have no trouble with that. Um, I hope that all of you are reconnecting. If you haven't already, you're reconnecting your friends to nature as well. This was one of the reasons why I did this book and why we have a website and why we have a mission here, which is to get people reconnected to their natural environment. And I want to thank the Central Coast Parks folks for all the work you're doing. This is all volunteer work for us. We don't make money doing it. We get the satisfaction of knowing that we're helping people understand their natural world and hopefully spreading that positive word wherever we can. So thank you, everyone, for being a part of this.
Thank you so much. Have a great night, everyone.